The weight shift formula. The weight shift formula is used whenever a weight is moved, added, or removed from an aircraft to calculate the change in the CG, because we know any change in the distribution of weight around the aircraft will change the position of the center of gravity. Now, before we go on and discuss how this applies to the aircraft or to loading an aircraft, I want you to know that weight shift formula can be applied to any system that has weight distributed around it. Do you remember the plank and the fulcrum example that we took to help us understand the weight and balance principles? We will use the same example and see how weight shift formula applies to that. The formula is weight moved, added or removed divided by total weight after moving, adding or removing equal to delta CG by delta arms. Delta is just a fancy way of saying the change in the CG divided by the change in the arms. The change in the CG is the value that we are looking for. More often than not, there can be other questions made a little harder for you in the written exams, which might involve playing with either one of these variables. So, taking the fulcrum example, we see that there is a 50-pound weight on the left of the fulcrum, 100-pound weight on the left of the fulcrum, and a 50-pound weight on the right of the fulcrum. The datum is right where the fulcrum is. We are going to assume the right side to be positive. So basically, if that is the fulcrum, the right side is positive. Now, let's see what happens to the system when you have this distribution. Calculating the CG is simple. We calculate the total moment and divide it by the total weight. In this case, the right side being positive, the moment on the right is 100 times 50, which is 5000. The moment on the left will be negative 25 times 100, which is negative 2500, plus negative 50 times 50, which is another negative 2500. So that is a total of negative 5000 on the left side. 5000 inch-pounds is the moment on the right and 5000 inch-pounds is the moment on the left. This balances the system, meaning the moment on either side of the fulcrum is equal, and hence the total moment is plus 2500 plus 5000 minus 5000, which is equal to 0. Total moment divided by total weight will be 0 divided by 200, which is 0, which means that the CG lies at 0 inches from the datum. In our case, that means the CG is right at the fulcrum. Let's see what effect does removing the 100-pound weight on the left have on the CG. We calculate using the weight shift formula. So the weight moved is 100, which we write over here. Then we have the total weight after, which will be 50 plus 50 on either side of the fulcrum, which is 100, equals delta CG, which is what we are looking for, divided by delta arms. Now delta arms is usually the difference between the initial position and the final position of the weight. Let's say we were to move the 100-pound weight to the right or to the left. We will then calculate the delta arms as the distance between the initial position of the 100-pound weight and the final position of the 100-pound weight from the fulcrum, which is the datum. Now, in our case, we are removing the 100-pound weight. Whenever you remove or add a weight, you always take the distance between the arms as the distance from the CG to where the weight is added or from where the weight is removed. In our case, the weight is removed, the CG is at 0. The weight is at 25 inches behind the datum or on the negative side. So the difference is 25 inches. I usually do not complicate this calculation by adding positive negative signs over here, but some people like doing that. How I solve it is a different way, just made a little simpler and using a little more common sense. So I put 25 as the delta arms. Now calculating this is not that hard. This will give us delta CG as 100 by 100, which is 1 times 25, which is 25 inches. This, as I said, people put positive and negative values because the CG can either move to the right or to the left. How I like to do it is use common sense. If the 100-pound weight is removed from the left, it means that the CG will move towards right because you are removing a weight from this side. Hence, the CG has to move to the other side. Another way to look at it is the moment of the 50-pound weight to the right is 50 times 100, which is 5,000. Moment of the 50-pound weight to the left is 50 times 50, which is 2,500. Hence, the moment of the right weight is more, and hence the CG will be towards right. And how much towards right? 25 inches. So the CG has moved 25 inches to the right of the datum. Our new CG will be 25 inches on the right.